Look out across the open ocean, and you are met with an illusion of endless, empty blue. For thousands of miles, the surface appears uniform, a vast watery desert tracking silently beneath the sky. Yet, just below the threshold of the waves, in the sunlit shallows of the tropical world, lies an environment of unparalleled complexity. This is the coral reef, a bustling, hyper-dense marine metropolis that defies the apparent emptiness of the surrounding sea. Though these biological structures cover less than 0.1% of the entire ocean floor, they play a disproportionately massive role in the health of our planet. Coral reefs are the foundational architecture for more than 25% of all marine life. Thousands of species of fish, invertebrates, sea turtles, and marine mammals rely on these habitats for food, shelter, and breeding grounds. They are rightfully called the rainforests of the sea. They are ancient, dynamic ecosystems, engineered over millennia by some of the smallest, most unassuming architects on Earth. To truly understand the grandeur of this underwater civilization, we must first look past the sweeping vistas of the reef and focus on the microscopic level, where the true magic of construction begins. At first glance, a coral reef appears to be a geological formation, a collection of brightly colored rocks, jagged ridges, and exotic plant-like structures swaying in the current. In reality, every square inch of this environment is alive. Corals are not plants, nor are they rocks. They are colonial animals. A single coral head is actually composed of hundreds, thousands, or even millions of individual, soft-bodied organisms known as polyps. Each polyp is a tiny, translucent creature, genetically identical to its neighbors, resembling a miniature sea anemone. It possesses a central mouth surrounded by a ring of stinging tentacles, which it uses to capture microscopic drifting prey. But the true engineering marvel of the polyp lies beneath its soft tissue. As the polyp grows, it absorbs calcium and carbonate ions from the surrounding seawater, chemically combining them to secrete a rigid, stony skeleton of calcium carbonate beneath its base. Over immense stretches of time, as generations of polyps live, reproduce, and die, these limestone cups stack upon one another, building upward and outward toward the light. What we perceive as a massive reef wall is actually a living veneer of active polyps sitting atop the calcified skeletons of their ancestors. It is a slow, monumental process of accumulation, where a colony might grow only a few millimeters to a few centimeters each year. Over centuries, however, this microscopic labor results in biological barriers so massive they can alter ocean currents and be seen clearly from Earth's orbit. Yet, this incredible feat of construction would be physically impossible for the coral polyps to achieve on their own. The open tropical waters where reefs thrive are remarkably nutrient-poor, lacking the abundant plankton needed to sustain such massive animal growth. To survive in these marine deserts, corals have formed one of the most celebrated and elegant symbiotic partnerships in the natural world. Tucked safely inside the translucent cellular tissues of the coral polyps live microscopic, single-celled algae known as zooxanthellae. This is a relationship built on a perfect trade of resources. The coral polyp provides the algae with a protected environment, elevated close to the surface where sunlight is abundant, as well as a steady supply of metabolic waste products like carbon dioxide and nitrogen, which the algae require for survival. In return, the zooxanthellae perform photosynthesis, converting sunlight into energy-rich sugars, amino acids, and oxygen. The algae share up to 90% of this photosynthetic food directly with their host polyp. This constant high-energy fuel injection allows the coral to secrete its limestone skeleton at a rate up to 3 times faster than it could without its microscopic partners. Furthermore, it is these microscopic algae, with their varied photosynthetic pigments, that give corals their spectacular, dazzling palette of neon pinks, deep purples, radiant greens, and golden yellows. Without the algae, the coral is merely a translucent tissue over a white bone-like structure. This cooperative energy production fuels an explosion of biodiversity. The physical architecture created by various coral species, ranging from the delicate branching staghorn corals to the massive convoluted domes of brain corals, creates a highly complex, 3-dimensional wonderland. The reef is a labyrinth of nooks, crannies, deep caves, overhangs, and vertical walls. This structural complexity provides an infinite variety of microhabitats, turning the reef into a magnet for life, where every organism evolves to occupy a highly specific ecological niche. In this crowded underwater city, competition is fierce, and cooperation is often the key to survival. Consider the daily interactions that play out across the reef matrix. Giant groupers and predatory moray eels regularly visit designated areas known as cleaning stations. Here, small, brightly colored cleaner wrasses and specialized shrimp boldly swim directly into the mouths and gill cavities of these massive predators. Instead of becoming an easy meal, the cleaners safely pick off dead tissue and harmful parasites, gaining a reliable food source while the predators receive essential medical care. Nearby, a clownfish finds complete safety within the venomous, stinging tentacles of a sea anemone. The clownfish has evolved a specialized mucus layer that protects it from the anemone's sting, allowing it to hide from predators that dare not approach. In return, the aggressive little clownfish fiercely drives away butterfly fish and other predators that feed on anemones, while its movements help circulate oxygen-rich water through the anemone's tentacles. Further along the reef crest, schools of parrotfish patrol the coral heads. Equipped with fused, beak-like teeth, these colorful herbivores scrape dead algae off the surface of the coral rocks, preventing the fast-growing algae from suffocating the living polyps. As the parrotfish digest the algae, they grind up the swallowed coral limestone, eventually excreting it as a fine, clean white sand. A single large parrotfish can manufacture hundreds of pounds of sand every year, actively building the iconic tropical beaches and sand cays that characterize reef ecosystems. At the top of this food web are the apex predators, reef sharks, barracudas, and jacks. By patrolling the edges of the reef and hunting the sick or weak, these predators keep prey populations healthy and in check, ensuring that no single species dominates and disrupts the delicate equilibrium of the community. Beyond its internal inhabitants, the reef serves as a vital nursery for the wider ocean. Many pelagic fish species, which spend their adult lives in the open ocean, travel to the calm, protected waters of the reef to spawn. The intricate coral branches offer the perfect sanctuary for juvenile fish, crabs, and lobsters to grow up, hidden away from the larger predators of the deep. The health of the open ocean is inextricably linked to the stability of the reef. If the reef collapses, the the ripples are felt across the global marine environment. Today, however, this ancient and delicate paradise is under an unprecedented siege. The primary threat to these underwater ecosystems does not originate in the ocean,